Determining the appropriate size of electrical metallic tubing, or EMT conduit for a specific set of conductors is crucial for ensuring both safety and code compliance in electrical installations. The National Electrical Code, or NEC, provides detailed guidelines for conduit fill, which dictates the maximum percentage of the conduit's cross-sectional area that can be occupied by conductors. These guidelines are designed to prevent overheating, facilitate wire pulling, and maintain the integrity of the electrical system. To calculate the minimum conduit size, firstly, identify the size and type of each conductor. In this case, we have 3 2 American wire gauge THHN conductors, 4 6 American wire gauge THHN conductors, and 3 10 American wire gauge THHN conductors. Secondly, refer to Chapter 9, Table 5 of the NEC to find the cross-sectional area of each conductor. For 2 American wire gauge THHN conductors, the area is 0.1330 square inches. For 6 American wire gauge THHN conductors, the area is 0.507 square inches. And for 10 American wire gauge THHN conductors, the area is 0.211 square inches. Thirdly, calculate the total cross-sectional area occupied by each type of conductor. 3 2 American wire gauge THHN conductors occupy 3 multiplied by 0.1330, which equals 0.3990 square inches. 4 6 American wire gauge THHN conductors occupy 4 multiplied by 0.507, which equals 0.2028 square inches. And 3 10 American wire gauge THHN conductors occupy 3 multiplied by 0.211, which equals 0.633 square inches. Fourthly, sum the total cross-sectional areas of all conductors. 0.3990 plus 0.2028 plus 0.633 equals 0.6651 square inches. Fifthly, determine the allowable conduit fill percentage. According to the NEC, for conduits containing 3 or more conductors, the maximum allowable fill is 40%. Sixthly, refer to Chapter 9, Table 4 of the NEC to find the available area for each size of EMT conduit. For 1-inch EMT, the area is 0.533 square inches, which is not sufficient since our conductors occupy 0.6651 square inches. For 1 and 1/4-inch EMT, the area is 0.804 square inches, which is sufficient. For 1 and 1/2-inch EMT, the area is 1.49 square inches. Seventhly, calculate the required conduit area. Divide the total conductor area by the allowable fill percentage. In this case, 0.6651 divided by 0.40 equals 1.66275 square inches. Since the NEC specifies a maximum fill of 40%, we need to find a conduit size that has at least 1.66275 square inches of usable area. Eighthly, compare the required conduit area with the available areas of different EMT conduit sizes. 1-inch EMT has an area of 0.533 square inches, which is less than the required 1.66275 square inches. 1 and 1/4-inch EMT has an area of 0.804 square inches, which is also less than the required 1.66275 square inches. 1 and 1/2-inch EMT has an area of 1.49 square inches, which is still less than the required 1.66275 square inches. This indicates that we need to revisit our calculation or consult a more detailed conduit fill table to ensure accuracy. Ninthly, let's re-examine the NEC tables to confirm our initial findings. Chapter 9, Table 5 provides more precise conduit fill information. We need to ensure that the total area of the conductors does not exceed the allowable fill for the selected conduit size. In our case, the total conductor area is 0.6651 square inches. Tenthly, using Chapter 9, Table 4, we check the allowable fill for different conduit sizes. For 1-inch EMT, the 40% fill area is 0.213 square inches. This is calculated by multiplying the conduit area 0.533 square inches by 0.40. Since our conductors occupy 0.6651 square inches, 1 inch EMT is insufficient. 11thly, for 1 and 1/4 inch EMT, the 40% fill area is 0.322 square inches. This is calculated by multiplying the conduit area 0.804 square inches by 0.40. Again, this is insufficient. 12thly, for 1 and 1/2 inch EMT, the 40% fill area is 0.420 square inches, calculated by multiplying 1.49 by 0.40. Still insufficient. 13thly, for 2 inch EMT, the 40% fill area is 0.860 square inches, 2.150 multiplied by 0.40. Now this is a possibility. 14thly, we need to also consider the physical limitations of pulling the conductors through the conduit. A larger conduit size may be necessary to ease the pulling process, especially with multiple conductors and bends in the conduit run. 15thly, while the calculations suggest that 2 inch EMT might be technically sufficient based on fill percentage alone, it's crucial to consider practical aspects such as ease of installation and future expandability. It may be prudent to opt for a larger conduit size to accommodate these factors. 16thly, consulting with a qualified electrician or electrical engineer is always recommended to ensure that the conduit size meets all applicable codes and safety standards. They can provide expert guidance based on the specific details of the installation. 17thly, it is also important to consider directing factors for conductors and conduit. When multiple current-carrying conductors are installed in the same conduit, their ampacity must be derated according to NEC Table 310.15. This derating can affect the allowable current-carrying capacity of the conductors and may necessitate the use of larger conductors or a larger conduit to maintain the required ampacity. 18thly, let's reiterate the key steps in determining the minimum conduit size. Firstly, determine the size and number of each conductor. Secondly, find the cross-sectional area of each conductor using NEC Chapter 9, Table 5. Thirdly, calculate the total cross-sectional area of all conductors. Fourthly, determine the allowable conduit fill percentage based on the number of conductors. Fifthly, use NEC Chapter 9, Table 4 to find the area of different conduit sizes. Sixthly, calculate the required conduit area by dividing the total conductor area by the allowable fill percentage. Seventhly, compare the required conduit area with the available areas of different conduit sizes. 18thly, consider practical factors such as ease of installation, future expandability, and conductor derating. 19thly, consult with a qualified electrician or electrical engineer to ensure compliance with all applicable codes and standards. 20thly, in summary, while the initial calculation might suggest a specific conduit size, it's crucial to verify this with the NEC tables and to consider all relevant factors to ensure a safe and compliant electrical installation. Remember that the goal is to select a conduit size that not only meets the minimum requirements but also provides sufficient space for easy wire pulling and future modifications. Therefore, the answer of 1 and 1/4 inch EMT initially provided is likely incorrect based on our detailed analysis and the NEC fill requirements. A larger conduit size, possibly 2 inch, is likely necessary to meet the code and ensure a safe and practical installation.